Imagine a future where disabilities don't limit individuals but empower them. With next-generation robotics and bionics, people with physical limitations are evolving beyond human capabilities, experiencing new levels of strength, precision, and independence. Today, we're diving into the world of advanced robotic parts that are transforming lives and even hinting at a new generation of superhumans. Bionic limbs, the future of prosthetics. Introduction to bionic limbs. Bionic limbs are sophisticated prosthetic devices designed to replace lost limbs with highly functional, mechanically powered substitutes. They can restore movement and functionality, offering a solution that is not only practical, but also emotionally uplifting for users seeking a return to a more active lifestyle. Technological advances. The integration of myoelectric technology allows these devices to respond to electrical signals generated by the user's muscle contractions. For example, users can flex their remaining muscles to control the movement of their bionic limbs, enabling nuanced motions such as turning a doorknob or holding a pen. Bionic limbs are also equipped with advanced sensors that enhance their functionality, enabling users to perform everyday tasks with ease. Customization and adaptability. Many modern bionic limbs, such as the LUKE arm, feature customizable designs to suit individual preferences and needs. Users can switch between different grip patterns, such as pinch, power grip, and precision grip, allowing them to adapt their bionic limbs for various tasks throughout the day. This adaptability is critical for enhancing the user experience, providing individuals with the freedom to perform everyday activities without the limitations imposed by traditional prosthetics. Research and development. Ongoing research aims to improve the sensory feedback systems of bionic limbs. Innovations such as haptic feedback, which mimics the sense of touch, are being integrated into devices. Researchers are exploring how to replicate the human sense of touch and pressure through vibration and other sensory cues, thereby making bionic limbs feel more like natural limbs. Exoskeletons for mobility and strength. Functionality and applications. Exoskeletons are wearable robotic suits designed to augment human mobility and strength. They provide support to individuals with mobility impairments, such as those suffering from spinal cord injuries, muscular dystrophy, or neurological disorders. By assisting with movement, these devices empower users to regain independence and participate in activities that might otherwise be impossible. Notable models. The ReWalk exoskeleton, one of the most recognized in this field, allows individuals with paraplegia to stand and walk by providing powered hip and knee motion. Users can control it through a combination of shifts in body weight and remote control inputs, allowing for natural movement patterns. Similarly, the ExoG exoskeleton offers powered movement assistance and is used in rehabilitation settings, helping individuals recover mobility after injury or surgery. Industry applications. Beyond rehabilitation, exoskeleton technology is being explored in industrial settings, where workers often face physical demands that lead to fatigue and injury. The Sarcos Guardian XO, designed for heavy lifting, reduces strain on the body and improves productivity by enabling workers to lift significantly heavier loads than they could otherwise manage. This dual-use capability could revolutionize industries such as construction, warehousing, and manufacturing. Future directions. Ongoing research aims to enhance the functionality of exoskeletons by improving battery life, increasing flexibility, and integrating AI for real-time adaptation to various environments. Future exoskeletons may also incorporate neural interface technology, allowing users to control them directly with their thoughts. Robotic vision enhancement systems. Overview of vision systems. Robotic vision enhancement systems are designed to assist individuals with visual impairments. They leverage advanced technology to improve the user's ability to see and interact with the world. This technology is particularly beneficial for those suffering from conditions such as retinitis pigmentosa, macular degeneration, and other forms of vision loss. Current innovations. Devices like eSight and Orcam Mye utilize high-resolution cameras and advanced processing algorithms to capture visual information and deliver it in a format the user can understand. For instance, eSight captures real-time video and enhances it with contrast and brightness adjustments, allowing users to see clearly in various environments. Orcam Mye, a small wearable device, can read text aloud, recognize faces, and identify products, empowering users with greater independence. Neural implants for motor control and sensory feedback. The concept of neural implants. Neural implants are devices embedded in the brain or nervous system that enable direct communication between the brain and external devices. This technology has the potential to restore mobility and function for individuals with paralysis or other motor impairments. Leading technologies. The BrainGate system represents a pioneering effort in this field, allowing users to control robotic arms or computer cursors using only their thoughts. Users learn to focus on specific intentions, which are then translated into actions by the device. Neuralink, founded by Elon Musk, aims to take this technology further by developing implants that can enhance cognitive functions, facilitate communication, and potentially restore sensory experiences. Integration with prosthetics. Neural implants are increasingly being integrated with prosthetic limbs, allowing users to receive sensory feedback from their devices. For instance, research at the University of Pittsburgh has demonstrated that users can perceive sensations such as pressure and temperature through their prosthetics, making the experience more intuitive and lifelike. Sensory feedback technology. Importance of sensory feedback. Sensory feedback technology enhances the functionality of prosthetics by providing users with tactile sensations, allowing them to perceive touch, pressure, and even pain through their devices. This feature is crucial for improving the user experience and restoring a sense of normalcy. Current innovations. Systems like Neurolife and Sense Glove are at the forefront of this technology. Neurolife connects directly to the nervous system, providing real-time sensory feedback to users. This enables them to feel objects they are touching with their bionic limbs, enhancing their ability to perform complex tasks. Haptic feedback mechanisms. Haptic feedback, which utilizes vibrations or forces to simulate the sense of touch, is being integrated into various prosthetic devices. This technology can mimic the sensations associated with different textures or forces, improving the user's ability to manipulate objects. For example, the Sense Glove allows users to experience the sensation of grasping objects in virtual environments, aiding rehabilitation efforts. Advanced hearing aids and cochlear implants. Overview of hearing technologies. Hearing aids and cochlear implants are essential technologies for individuals with hearing impairments. Advanced models provide not only amplification, but also improved clarity and sound differentiation in complex listening environments. Current innovations. Devices like Audicon More utilize machine learning algorithms to process sounds in real time, filtering background noise and enhancing speech clarity. Cochlear implants are also evolving, with models that offer wireless connectivity to smartphones and streaming devices, allowing users to integrate audio from various sources seamlessly. Research and development. Researchers are developing cochlear implants that can simulate a broader range of frequencies, improving sound quality for users. Innovations such as 3D audio processing are being explored to help users identify the direction of sounds, significantly enhancing situational awareness. The integration of next-generation robotic parts and technologies is set to transform the lives of individuals with disabilities, offering unprecedented levels of mobility, independence, and functionality. As these innovations continue to evolve, the dream of transforming the disabled into superhumans becomes more attainable. Society's commitment to advancing these technologies not only enhances the quality of life for individuals with disabilities, but also fosters inclusivity and empowerment in a rapidly changing world. Through collaboration between researchers, developers, and users, we can pave the way for a future where disabilities are no longer barriers to achieving one's full potential.